Now at this point we can use a fuse node. Now two neighboring primitives share the same points at the connecting edge. This gives us two new tools for future condition tests. For one, we have a color gradient on those primitives, and second, it creates an average value for the corner normals. We will use both in later stages, but now I need to create a corridor ID. I need a way to tell the system that these primitives belong to the same corridor. Before I can do that, I need to single out all the corridors. That's easy enough because of our newly created attribute structure. When we display primitive numbers, we can see that there are quite a few of them. I want a unique ID for each side of the corridors. An easy way would be to simply combine all of them to one primitive and use the primitive number as ID. For that we can use the divide node. Select remove shared edges and all of the inner edges disappear. We still have the points, but they are not in the way. In fact, we will use them later. Again, you have the option to use subs for the task at hand. I want to transfer the primitive number into a new attribute called corridor ID. You could either use an attribute create node or simply create an attribute wrangle where you create it directly. Of course, I choose the wrangle solution. The corridor ID will be crucial when it comes to creating all the details in the corridors. So it makes sense to once again create a visualizer. Sometimes it makes sense to push your important variables into attributes just so that you can create a visualizer and make it very easy for you to debug your logic. This wrangle did nothing special, so obviously it worked, but I want corridor ID to have another interval than the primitive number, so I add 1 to the primnum. Next we have to somehow bring our new corridor ID back to our original corridor pieces. Now for the experienced Houdini user, an attribute transfer node pops into mind. But sometimes it's not as easy as it sounds. In a setting like this, the attribute transfer node can have a problem. Let me show you what I mean. I connect the geometry with the corridor ID into the second input, and as you can see, the corridor ID gets transferred onto our main geometry. Looks good on the first glance. But this is what I was talking about. In some cases, the distance between the areas can cause problems for the transfer node. When I change the distance threshold, you can see how less and less primitives get their ID. But when I increase the distance, here at this specific corner, it's not the ID 1 that should be there, it's the ID 5 from below. So let's get rid of the transfer. Before I spend too much time on fixing this, I write my own transfer node with a wrangle. The wrangle node will get the corridor ID for my main geometry, so that has to go into the first input. The already created corridor ID goes into the second input. Then I can go into the editor, and again I start with the usual variables when I use point clouds. The int handle pcloud. In addition, I need an int array for primitive numbers, a position vector, and again the int array for the points. I directly fill it with the prim points of the current primitive. Now, as I said earlier, when we used divide to get one single primitive, we kept all of the points, and this helps us now. It allows us to use the for each loop to go over each point of the main geometry, get the position information of a point from that primitive, and then use it to open the point cloud with the data coming in on the second input with a very short distance. And we only expect one point there. Each point should always find a point on the second input. But even if you're sure you know the outcome, create the control mechanism anyway, just as a best practice. But once we have found that point, we can use PC import to get to the point number. And of course we should also define the variable that we use for the copy by reference. Point number returns an int, so the variable is int found. Now that I have the point, I want to get the one big primitive that holds the corridor ID. I use point prims, which returns an array, even though unnecessary since we know it's only one primitive, but that's how the function works. But knowing that, I can use prim to get the corridor ID and just use the first and only element of the array prims. Only thing left to do is take that ID and set it as new primitive attribute on the current primitive. That worked perfectly fine, and we no longer have a problem with the distance. We still don't have a problem with performance, but this for each loop takes a few unnecessary turns. I leave that open and hit you with why that's the case in the course questions. But another optimization that we haven't used yet, when using point clouds inside of a loop, you should, just to be sure, close that point cloud. Otherwise, you run the risk of memory issues. But now that we have the corridor ID, we have to think about how we can get a gateway ID.